All right, so page 456, number 10, that's at the top of the page. It's dealing with parole. The information that we have is that we have a Z interval. Okay, this is a Z interval, and it's 95% confidence, and we've got 0.0561, I'm just going to leave it at that, is less than P, parole, is less than 0.625. And this is the, out of N is 902, out of 902 parole decisions. So in other words, people came before a parole board and they decided to grant parole or not. And so it looks like these, I'm guessing that this would be the percent of the parole cases that people got paroled. That's all we can assume here. So it says, what can you conclude? So what can you conclude? Here's the interval. A question like this is asking you basically to do step 4 from confidence intervals. And step 4 is where we interpret our interval. Okay, so when you interpret your confidence interval, you would say that I am 95% confident that the interval from 0.0561 to 0.561 to 0.625 captures the true proportion of those paroled in Nebraska. So that's step 4 of a confidence interval. I'm 95% confident that the interval from 0.561 to 0.625 captures the true proportion of those paroled in Nebraska. Okay, now question 10 doesn't ask these questions, but I want to ask a few questions here. So I'm going to add, we'll call this part A. I'm going to make up a part B. What is the margin of error? What is the margin of error in this confidence interval? Okay, so a confidence interval, if you recall, the formula is your point estimate plus and minus your margin of error. Okay, your point estimate could either be P hat, or what's the other thing it could be? X bar. Okay, plus and minus. Your margin of error is made up of two things. Your margin of error is made up, in the case of P hat, of your z-score times your standard error. And what is the standard error for P hat? Thank you very much, Mira. The square root of P hat, Q hat, all over N. And for X bar, the critical value is the T critical value times the standard error. And what is the standard error for a mean? Very good. Standard deviation over the square root of N. Now, this you also have degrees of freedom is equal to N minus 1 when you're dealing with X bar. Okay, so which of these are we dealing with in our interval 0.561 to 0.625? Is this a P hat or a mean? It's a P hat. You can usually tell the difference because the P hats are decimals, but be careful because you can have means that are decimals too. So you have to read the problem, okay? And this isn't that great. It just says a Z interval. Here's how, I mean, you can tell the difference. If it's a Z interval, it has to be p hat. If it's a t interval, it has to be a mean. All right, so we want to find in this interval the margin of error. So the point estimate, where is the point estimate always located in your interval? What? In the middle. The point estimate is always the middle of your interval. Always. Okay, so whatever number would be right in the middle of these two was your point estimate. Okay, and the margin of error, well, isn't the margin of error what you add and subtract to the middle to get these numbers? Okay, so any ideas on how we could find the margin of error? How? We could, but a lot of times, like in a problem like this, they might not give you n. So usually we wouldn't even know n, so we can't really calculate it. So if you couldn't calculate it, how would you find it? This is a very simple thing. What? Okay, so we would need to find halfway between the interval, right? How do you find halfway? How do you find the middle? So find the middle. How do you find the middle? How do you find the middle of two things? What? Add them together and divide by. Isn't the middle the average? So if I add these two, find the middle. Average. Average. Add them. 0.561 plus 0.625 and divide by 2. Got it? What's the middle? You should have it already. You should be just using your calculator. Okay, so right in the middle is 0.593. So that was your point estimate. This was my p hat, right there. Okay, so how do I find the margin of error now? Nope, this is the number that's in the middle of these two. So if you were to make a number line, here's 0.593, here's 0.625, here's 0.561. We're looking for from here to here. That's the margin of error. How do you find that? You subtract. That's all you do. This is a very simple thing. You take 0.625 minus 0.593, or you could take 0.593 minus 0.561. What is the distance between these two things? That's the margin of error. So 0.625 minus 0.593. So 0.032 would have been the margin of error. Now, there's another way to find the margin of error. Isn't the distance between these two numbers twice the margin of error? So the distance from here to here is the margin of error 2 times. So I could have just subtracted 0.625 minus 0.561 and got 0.064 and then divided that by 2. Because if the point estimate is in the middle and you add and subtract the margin of error to that, the whole distance of your interval is twice the margin of error. So I subtract and divide by 2, and look, it gives me the same answer. All right, so the next problem I want to look at is a problem to find n. And this one is going to be number 33 on page 458. And this says that during a routine screening, wrong one. A state's environmental agency worries that many cars may be violating clean air emission standards. The agency hopes to check a sample of vehicles in order to estimate the percentage with a margin of error of 3%. Okay, so margin of error of 3%. To gauge the size of the problem, the agency does a little survey, and they sample 60 cars, and they find that 9 have faulty emissions. Okay, so 9 out of 60, or 0.15 in their little preliminary sample, had bad emissions. So now the question is, how many should be sampled? How many to sample for a full study in order to get this margin of error of 3%? So now I can relate you to 2 pages in your notes. Page 132 and page 137 in your notes have similar problems to these where we're finding N. So I'm just going to work this out, but just in case you want to reference these, review a little more. How many in the sample? In other words, we're looking for N. So if we want our margin of error to be 3%, we say, well, that's my equation. Margin of error equals 0.03. So what is the margin of error for a proportion? We just wrote it on the other page. What was the margin of error for a proportion? It's right here. Z times the standard error, and the standard error is the square root of p hat q hat over n. So I want Z times the square root of p hat q hat over n to be equal to 0.03. Now, what is the z-score for a 90, let's see, they say 90%? What's the z-score for a 90%? .645, okay. Now, they do a preliminary study to give us a p hat. But when we talked about it in our notes, we didn't have that preliminary study. What do we use if they don't give us some information? What do we use for p hat times q hat? Casey? Well, we use 0.5 for p hat and 0.5 for q hat, so 0.5 times 0.5 would give us 0.25. So if they don't give you this, then you use basically 0.25 for the top. But they gave us 0.15. So the Q is 0.85, and we're looking for N. Our question is, how many cars do we need to test? So now that we have this set up, we just need to solve the equation. So to solve it, I'm going to first divide by 1.645. That'll get rid of the 1.645. Then to get rid of the square root, I square both sides. Then to get rid of divided by N, I times by N. So what I have now is 0.15 times 0.85 equals this mess. And to get rid of times that big mess, I just divide by that whole thing. And so now I'm just going to type that in my calculator, making sure I put parentheses around that 0.15 times 0.85. Okay, again, you can't sample 383.35 cars, so you just go up. Don't round, don't go down, you just always go up. Assume you just, to make sure you get that margin of error, just go up to the next one. So you should sample 384 cars. Alright, so now quick review on the 2 different types of confidence intervals. We have the confidence interval for a proportion, p hat plus and minus z times the square root of p hat q hat over n. And then we have x bar plus and minus t times the square root, or s over the square root of n. And this has degrees of freedom n minus 1. And you've got 4 steps. So what's step 1? Well, that's basically the intro. That's where you say, I'm trying to estimate this. My best guess is I'm probably wrong, so I'm going to make you name the interval. Step 2 is your conditions. The difference here for the p hat, condition 3 is the thing that's different.